Hi, my name is Mike O'Keefe and I'm a UNH Marine Docent. This is another video in the SCUBA SeaTrek series in which we're using scuba equipment to demonstrate some scientific principles associated with scuba diving. In this video we're going to talk about thermal conductivity, specifically thermal conductivity of air and the equipment that scuba divers use to protect themselves from cold water. Scuba divers use really two different suits to wear to protect themselves from cold water. And the reason they have to do that is that water is much more thermally conductive than air is. And by thermally conductive, I mean that it transfers heat a lot faster than air does. 70-degree air feels very comfortable to us. However, 70-degree water, most of us would agree, feels a little bit chilly. And particularly here in New England, when the water temperature really gets above 50 degrees, divers really need to protect themselves from that cold water in order to stay warm. There's two suits that a diver uses to do that. First is a wetsuit. This is just made out of neoprene rubber, and it's called a wetsuit because the diver actually gets wet. The water gets trapped in the neoprene, and then the diver's body warms that water, and they're able to stay warm. These are generally good in temperate water conditions. They above 65 degrees Fahrenheit. Once you get below 65 degrees Fahrenheit, most divers will use a dry suit. And a dry suit is just that. It's waterproof, has neoprene seals on it, and it keeps the diver dry, so a diver is able to just wear fleece garments or jackets just like we would on any cold winter day in order to stay warm. So I'm going to do a little experiment here to demonstrate just how thermally conductive water is. So we're in this room right now. The air temperature is about 60 degrees. I've got a basin of water here. It's filled with ice. My body temperature is about 98 degrees Fahrenheit, just like everybody else. And I'm going to put my hand in the water for 15 seconds and then take the temperature using this infrared thermometer. And then I'm going to repeat the experiment wearing a dry glove, and we can compare what the temperatures are. So here we go. 1, 2, 3, 4, 5. Boy, this is really cold. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so right now the temperature on my hand is saying 57 degrees Fahrenheit. So I'm going to put this dry glove on, and I'm going to put my hand in the water for 15 seconds again, and then we'll measure the temperature. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Boy, I could just barely feel the cold. And I take the temperature of my hand, and it's reading 96 degrees Fahrenheit. So you can see just how much warmer the dry glove kept my hand and protected me from the cold water. Now you can do an experiment on your own to look at the difference in thermal conductivity between water and air. If you get a glass of water, let it come up to room temperature, and then take 2 ice cubes that are about the same size, put one in the glass of water, and put another on in a dish right beside it, and see which one melts fast. So I want you to do that experiment and report back on the results. That's all for this video. Thank you for watching.